This is Swati Suntari from Department of Mathematics SF, V.V. Vaniya Perumal College for Women, Virudhunagar. In this video, we are going to learn about correlation. So correlation is nothing but association or relationship between any variables. In our day-to-day life, we have come across so many relationships, associations between humans, variables or objects. But how can we measure it? The variables are how long they are strongly connected or strongly associated. Here we can calculate the measurement between the association. That is called correlation. Before we going to learn about correlation, we should know about covariance. The covariance is the study of direction between two variables. And the correlation is the study of direction and the measurement of relationship between the two variables. There are three types. These are the three main types. The first one is positive correlation. It is a relationship between the two variables which are moving towards in the same direction. For example, height and weight of the human. Because the height is increases, the weight is also increases in the human. And negative correlation. It is a relationship between the two variables which are towards moving in the opposite direction. Because one variable is in increasing mode, the other will be in decreasing mode. For example, in a hill station, the temperature of the hill station is very low. But the height of the hill station is above, very above in the sea level. So the variable's height above the sea level and the temperature is in the negative correlation. And the last one is no correlation. Here there is no relationship and association between the two variables because they are independent to each other. We cannot compare or we cannot relate it to each other. For example, tea drinkers and their intelligence level. And the range of correlation between lies in -1 to 1. And the positive correlation is visualized here. All the variables are densed in the same line because they are increasing mode. And in the negative correlation, the variables are in the opposite direction and they are dense in the downward position. And in the no correlation means all the variables are discrete and all the variables are scattered plot. Next, the correlation coefficient is measured by the formula which is known as Pearson's correlation coefficient because the correlation coefficient formula is developed by Karl Pearson. Here the formula is R equal to covariance of x comma y divided by sigma x and sigma y. Covariance of x and y means summation xi minus x bar into yi minus y bar divided by n. And standard deviation of x means sigma x, which is calculated by square root of summation xi minus x bar the whole square divided by n. And sigma y is nothing but standard deviation of y, which is calculated by square root of summation yi minus y bar the whole square divided by n. And now we are going to solve the problem, which is very helpful to understand this concept. So here the height and weights of the 5 students are listed here. Height is in the unit of centimeter and weight in the unit of kilograms. So height is here measured 160 centimeter, 161 centimeter, 162 and 163 and 164. And weights are 50, 53, 54, 56 and 57. Here we are going to find the correlation coefficient between the height and weight. And here the variable x denotes the height of the person and y denotes the weight of the person. And we are going to find the correlation coefficient. We first find x bar, y bar, covariance of x comma y, sigma x and sigma y. And next we are going to tabulate these values by using the calculation very easily. So height are listed in the first column 160, 161, 162, 163, 164 and weight are listed here 50 up to 57. And first we are going to find x bar. So how to calculate x bar? We are going to sum up all the values of x 160, 161, 162, 163 and 164 we get summation xi which is 810. And this is divided by the n value. N is nothing but 5 students. So we are going to divide by 5. So 810 divided by 5 means 162. And we are going to calculate y bar. The formula is summation yi divided by n. So summation yi means we are going to sum up all the values of y. So 50 plus 53 plus 54, 56 and 57. So we get 270 and 270 is divided by 5, we get 54. And we are going to find x minus x bar because we find covariance of x comma y. So x minus x bar means x minus 162. So 160 minus 162 we get minus 2, and 161 minus 162 we get minus 1, and 162 minus 162 we get 0, and 163 minus 162 we get plus 1, and 164 minus 162 we get plus 2. And similarly we are going to find y minus y bar. Here y bar is 54. So 50 minus 54 is minus 4. 53 minus 54 is minus 1. 54 minus 54 is 0. And 56 minus 54 is 2. And 57 minus 54 is 3. And we are going to multiply these two columns. So minus 2 into minus 4 we get 8. And minus 1 into minus 1 is 1, 0 into 0, 0, and 1 into 2, 2, 2 into 3 is 6. So we are going to sum up all the values. So summation x minus x bar into y minus y bar is 17. And the covariance formula is summation x minus x bar y minus y bar divided by n. So we are going to find 17 by 5. And we are going to find sigma x, we have to calculate x minus x bar the whole square. So we are going to square the column of x minus x bar each. So minus 2 the whole squared is equal to 4, and minus 1 the whole squared is 1, and 0 squared is 0, 1 squared is 1, 2 squared is 4. So we are going to sum up all the values. Summation x minus x bar the whole squared we get 4 plus 1 plus 1 plus 4 we get 10. So sigma x square root of summation x minus x bar the whole square divided by n. So square root of 10 divided by 5 we get square root of 2. And similarly we are going to calculate y minus y bar the whole square. So we are going to square the column of y minus y bar. Minus 4 the whole squared is 16, minus 1 the whole squared is 1, and 0 is 0, 2 squared is 4, 3 squared is 9. So we are going to sum up all the values. Summation y minus y bar the whole squared is 30, and we are going to find sigma y is equal to square root of 30 by 5, we get root 6. And we are going to substitute all these values in the correlation coefficient formula, which is covariance of x comma y divided by sigma x sigma y. So covariance of x comma y value is 17 by 5, and sigma x is root 2 and sigma y is root 6. So we are going to calculate these value. We get 0.98, which is approximately equal to 1. So the height and weight are strongly positive correlated. All the values here is measure the correlation coefficient value. Here R is 1. That means perfect positive correlation between the two variables. And if R is 0.9, that are strongly positive. And 0.5 means weakly positive. And 0 means the two variables are uncorrelated. There is no correlation. And minus 0.5 means the two variables are weakly negative correlation. And minus 0.9 means that are strongly negative correlated, and minus 1 means that are perfectly negative correlation. So in this video is very useful to understand the concept of correlation. Thank you.